So for the second part of this review, writing equations. This you can see, the equation's basically going to be of the form y equals plus or minus a times whatever your function is times b times x minus c plus d. The thing that's always easiest to pick out is the value of d, that's the midline, graph it in. Then your amplitude. On this one, if you were graphing it yourself, going backwards, you can see you've gone up one and down one. Put these marks on your paper. So you can see that D is, it hasn't been shifted up above the x-axis. So our value of D is going to be 0. Our value of A, it's only going up and down 1. And so that was D and A. B is going to be based on your period. We read the period from the graph, and that's going to equal 2 pi divided by b. And we're going to use this equation to work out what b is. So first of all, we have to work out what the period of the graph is. Look at one step, say going from anywhere, this mid to this low, thinking of high, middle, low, middle, high, or whatever. One step equals pi by 2. So the period will be 4 steps. So 4 times pi by 2, which is 2 pi. So our period equals 2 pi from the graph, and the equation tells us it's 2 pi over b. So we know that b must be 1. So in this equation now, we know the value of d, we know the value of a, we know the value of b. We just need the value of c. Now that depends on the pattern. If I call this one start number 1, this is starting at a high, then going to a mid, then going to a low, then going to a mid, then going to a high. So this is the start. Number 1, this purple one is the start of a positive cosine from high, middle, low, middle, high. That's a pattern of a positive cosine. And it's been shifted left by pi by 2. So the c, we'd have x plus pi by 2. So for start number 1, we're writing a positive cosine, y equals positive cosine. A is 1, so I don't need to put anything in front of that. B was also 1, so I don't need to put anything in front of the x. Then I'm going left by pi by 2, so I put plus pi by 2, and it wasn't going up or down at all. So that's just that one. We'll have another colour. No, not really. Yeah, I wonder if this one will work. Let's try this colour. I think it's going to be a black pen. It looks pink, but it's not going to be pink. Okay, starting here, I'm starting at the middle. I'm going middle, low, high, middle, low, middle, high. Then it'd be to the middle again. That's a negative sign. Okay, this is the start of a negative sign on the y-axis. So that'd be where c equals 0. Middle. So for number 2, this one here, y equals negative 1 for the asymptote, negative sign of just x. It's not been shifted at all. Oh, that was rather boring. Good grief. Okay, let's have a look at the next one. Number 9 was very boring. Okay, on this, the midline, our value of d equals negative 1. Our amplitude, we're going up 2 and down 2. So amplitude equals 2. Then we need to know the period. So the period, let's see, from say this low to this low, that's a complete period. You could do one step, which is pi by 4, and multiply it by 4, which will give you pi. And on this one, you can see a complete period, and it finishes at pi. So these are sine and cosine waves. We know that is 2 pi divided by b. So cross multiply here, we can see that b equals 2 pi divided by the period. So it's 2 pi divided by our period, which was pi. We can see it's 2. This is like 2 pi over 2. B must be 2. Okay, so we've got a value of D, we've got a value of A, we've got a value of B, and now we just need 2 different values of C. For this one, our C equals negative pi by 2, and for this one, our C equals, well, if that's pi by 2, this must be a fourth, positive pi by 4. So let's do the red equation first, and what we need to do is recognize the pattern. So just start anywhere on your wave. Well, let's start at this one. That's a high point. Write out your pattern. It's going high, then this point here would be middle, then this point here would be low, then this point here would be middle, then this point here would be high, then it would go middle, and just repeat, repeat, repeat. This red one here is starting high, middle, low, middle, high. That's a positive cosine, red. So y equals positive cosine. What's my A? Put that in front of the cosine. Times B, my value of B is 2, parentheses x minus negative, that turns into plus, pi by 2. Close both parentheses, plus the value of D. Oopsie, that was minus 1. Okay, A is 2, B is 2. C is negative pi by 2, so you're subtracting a negative, that's plus. D is minus 1. So this is for this start here. For this start here, I'm starting at a middle and going high, middle, high, middle, low. That is the start of just a regular sine wave, a positive sine wave. So this would be y equals plus 2 sine of 2 times x, and this one C is pi by 4. So I'm not adding pi by 2, I'm subtracting, because I'm going to the right, pi by 4, close both parentheses, and the value of D is the same. So that was those ones. Okay, let's do this one now. Right, this is obviously, there's a high, there's a low, this is a mid value. Our value of D equals 1, and this is going up 3 and down 3. A equals 3, period. If that's pi by 2, this must be pi by 4. This is a middle, high, middle, low, middle, high. I don't have much about this wave at all, but I can see that one step length, one step equals pi by 4. So 4 steps, which would be the period, must be pi. And I know that the period equals 2 pi divided by b. So multiply top and bottom by 2 there. B must equal 2. Or you could cross multiply and divide, however you want to solve that when you can. So I know B equals 2, I know D is 1, I know A is 3, and then I just have 2 different values for the C. This one, C equals pi by 4. How far? That's how far you are going from the y-axis. And this one, you've been shifted to the right by pi by 2. So on this one, C equals pi by 2. For the red one, we're starting on a low, low, middle, high, middle, low. That's the beginning of a negative cosine. And for this one, you're starting on the midpoint, going high, mid-high, mid-low. That's for just a regular sine, positive sine. So let's fill these in. this equation is y equals negative, then I need the a, and a was 3. Negative 3 cosine of b, which is 2, parentheses x minus c, x minus pi by 4, close both parentheses, then add on d plus 1, okay? Do not bother distributing that. Leave it with all those parentheses. That's graphing form. Then for the purple one, starting here, this was the beginning of a positive sign. So it's going to be y equals just positive 3 sine of 2 times x. The only thing that'll be different between these is this horizontal shift. That one was shifted pi by 4 to the right. This one shifted pi by 2 to the right. So to the right, so you're subtracting. Close both parentheses plus 1. The a, the b, and the d on both of them should be the same. The c changes along with the pattern. Okay. And this last one, well, how can I tell if that's a sine, cosine, tangent, cotangent? Well, if it's a tangent or cotangent, there'd be an asymptote. I think from the shape of this, this is a high point, this is a midpoint, that's a low point, and it's going up again, okay? So this is the beginning of a positive cosine. This one is the beginning of middle, low, middle. This is the beginning of a negative sine. Oh, our midline is here at -2. Our amplitude, we're just going up and down 1. Our amplitude is simply 1. Our period, 1 step is this distance here. That's going from the markings, if this is pi by 2, this must be pi by 4, 2 pi by 4, this is 3 pi by 4, 4 pi by 4 is pi, yeah? So our step, 1 step equals 2/4 of pi, which is basically pi by 2. So there are 4 steps to the period, which is telling me the period is 2 pi, which is normal for a sine or cosine wave. So I know that b is 1, it's not being compressed. Then we just need our starts. The start for this positive cosine is at pi by 4. So we have y equals positive cosine, a was 1. Don't need to put anything for that. Don't need to put in the positive. Cosine of b is 1. Don't need that. X, minus pi by 4. It's been shifted pi by 4 to the right. And then I need my vertical shift, which is down 2. So that's for this start here. And I'll do this one in red. When I've been shifted 3 pi by 4 to the right, we're starting with a middle low, so we knew it's a negative sign. Y equals negative sign. Again, the amplitude in here and in here was just 1. The b is just 1, so I don't need to put anything in when you're multiplying by b, when you're multiplying by 1. X minus, and our horizontal shift this time was 3 pi by 4, sometimes called the phase shift, minus 2. Okay. This year we don't have to do question 13. That's good, because I'm getting tired of doing this review. Find exact values of theta such that tangent is negative. Well, if tangent is negative, that's either x or y is negative, but not both. One of them is negative, but not both. So they're not both positive. I'm not in quadrant 1. They'd both be negative there. I'm not there. I've either got a triangle in quadrant 1 or quadrant 3. So I recognize root 3 over 3 has come from somebody writing 1 over root 3 and rationalizing it. Yeah. So tangent is y divided by x. So I'm going to draw two triangles, one in quadrant 2 and one in quadrant 4. I knew that because the tangent was negative. That's what I was doing here. And I know my y is 1 and my x is, I'm looking at this where I sort of unrationalized it. My x is the square root of 3. So I recognize that triangle. This is a 30, 60, 90, where this is the short leg. So this is the small angle. It's 30 degrees, which is basically pi by 6. My reference angle is pi by 6 or 30 degrees. And in quadrant 2, my actual angle, this angle here, in quadrant 2, that'd be 5 pi by 6. And in quadrant 4, this angle round here must be 11 pi by 6. Oh, good grief, I've written much too big. I haven't got room for the next question. Okay, cosecant theta is root 2 over 1. So cosecant is r divided by y. It's positive. So if it's positive, the y must be positive because, and it couldn't be negative y and negative r to give me a positive. It must be that y is positive. So I'm going to be in these two quadrants here and here. And y is 1, 1, r is root 2. So my reference angle here, this is a 1, 1 root 2, so 45 degree, which in radians is pi by 4. I've got one answer in quadrant 1, and I've got another answer in quadrant 2. Okay, 2 values for there. Do red for this one. Cosine is x over r. If it's negative, well, r is negative, negative. R is never negative. So it must mean I've got a negative x. So if x is negative, I'm not in quadrant 1 or quadrant 4. I'm in quadrant 2 or quadrant 3. So let's draw triangles in quadrant. Well, those are terminal rays. Make them into triangles by linking them to the x-axis. I know the x is negative the square root of 3. This is 2, this is 2. So that's a 30, 60, 90, where the angle here is the small angle, it's 30 degrees. My reference angle is 30 degrees, which in radians is pi by 6. So in quadrant 2, the angle over 6 is 5 pi by 6. And in quadrant 3, my angle is 7 pi by 6. And just evaluate now. What colour shall I use now? Oh, I'm so looking forward to this being done. I've had enough. Secant 5 pi by 3. Now, when you're evaluating, we get you to draw the terminal ray first and then recognize which triangle it is. 5 pi by 3. The numerator is nearly double the denominator. I'm in quadrant 4. That's my terminal ray. Turn it into a triangle. And to evaluate a secant, it's going to be the ratio of two sides. This is the angle we've just drawn there. We've just drawn the angle that ends on that ray. That's 5 pi by 3. And so my reference angle for anything divided by 3, my reference angle is 60 degrees. So if this is a 60-degree triangle, this would be the square root of 3, but we're going down, so it's negative. And the x would be 1, positive, because we're going to the right, and the r would be 2. Secant is the ratio of r divided by x, so it's simply 2 divided by 1. Well, that was easy. Next question. I'll do it in blue if this blue pen works. No, that wasn't the blue pen. Was this the blue pen? I don't know. Cotangent 3 pi by 4, I'm going to want the ratio of x divided by y, so I need a triangle for that. So I'm going to draw a triangle based on 3 pi over 4. 3 pi over 4 is in quadrant 2, and that's based on pi by 4 is my reference angle, which I know is 45 degrees. So I'm just labeling this up as a 45, 45, 90, 1, 1, root 2. If I'm in quadrant 2, this x would be negative. So now I just say that was the angle here, 3 pi by 4. I just want, for the cotangent, I just want the ratio of x divided by y. My x is negative 1, my y is 1. So that's negative 1. And the last one, yay, nearly finished. Negative 7 pi by 6. Well, I know my reference angle is going to be on 30 degrees because of this denominator, but I have to know which. It's either going to be here, 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 or here. I'm going backwards 7 pi by 6. So I'm going backwards more than 6 pi by 6. I'm going backwards to there. It's this triangle. I'm in quadrant 2. Now just label that triangle up as a 30, 60, 90, where this is 30. So this is the short leg, this is the long leg, the radius is 2. I'm not in quadrant 1, so something's got to be negative, and in this quadrant it's the x. So my x is negative root 3, my y equals 1, my r equals 2. Which of those two of those do I need? Sine is y divided by r. My y is 1, my r is 2, so the value of the sine of negative 7 pi by 6 is 1/2. Woo, we've finished. I hope I was recording.